next problem is a uniform metal disc of diameter 0.1 meter and mass 1.2 kg is fixed symmetrically to the lower end of a torsion wire of length 1 meter and diameter 1.44 into 10 power minus 3 meter. The upper end is fixed. The time period of oscillations is 1.98 seconds. Calculate the rigidity modulus of the wire. Here, given data should be written on the basis of metal disc and the wire. For metal disc, the diameter is given as 2r is equal to 0.1 meter and mass capital M is equal to 1.2 kg. For wire, the length is given as 1 meter, the diameter 2r is given as 1.44 into 10 power minus 3 meter, and then the other parameters given are T is equal to 1.98 second, the period of oscillation. The solution is calculate the rigidity modulus of the wire. Rigidity modulus as the formula based on torsional oscillations is 8 pi IL divided by R power 4 T square Newton per meter square. Here I is the moment of inertia of the disc, L is the length of the wire, R is radius of the wire, T is period of oscillation. I value is moment of inertia of the disc is taken as I is equal to m r square divided by 2 kilogram meter square. The mass of the disc is 1.2 kg and the diameter is given as 0.1 meter. Therefore, radius is 0.1 by 2. It is 0.05 meter. So, m is 1.2 kg and r square is 0.05 the whole square divided by 2. I am using calculator here. Even switching it on, double bracket 1.2 into 0.05 the whole square. I am closing it with single bracket divided by 2 and then closing it with double bracket. I'll get I is equal to 1.5 into 10 power minus 3 kilogram meter square. Substituting I value in this formula, I'll get eta is equal to 8 into pi 3.14. I is 1.5 into 10 power minus 3. L value is 1 meter divided by R power 4. Here 2R is 1.44 into 10 power minus 3 meter. Therefore, R is equal to this divided by 2 will give you 0.72 into 10 power minus 3 meter. So, 0.72 into 10 power minus 3 the whole power 4, T square value is given as 1.98 square. 1.98 square. Using the calculator, I am going to solve it. Switching it on, double bracket 8 into 3.14 into I value is 1.5 into 10 power minus 3 into 1, closing with single close bracket divided by 1 close bracket 0.72 cap 4, that is power 4, into 10 power minus 3 power 4 into 1.98 square. Closing with double bracket, I got 3.576 into 10 power 10. So I am writing here rigidity modulus n or eta is equal to 3.576 into 10 power 10 Newton per meter square. Next problem is a bar of length 1.5 meter is clamped horizontally at one end and a load of 0.1 kg attached at its free end. Calculate the depression at the loaded end if the Young's modulus of the bar is 9.78 into 10 power 10 Newton per meter square and its breadth and thickness are 0.024 meter and 0.005 meter respectively. So from this problem, we can identify this problem is about cantilever. A beam or a bar of a particular length is fixed at one end, clamped at one end, and it is loaded at the free end. So it is a cantilever problem. So the given data is the length is given as 1.5 meter and then load mass is given as 0.1 kg and then Young's modulus is 9.78 into 10 power 10 Newton per meter square. The breadth is 0.024 meter and the thickness is equal to 0.005 meter. So the parameter to be determined is the depression at the loaded end. Depression y is equal to, we are going to solve it. Solution. Depression at the loaded end. For cantilever, we have the general formula W L cube divided by 3y Ig in meters. We know that W is m into g. Ig, in this problem, it is given as a beam or a bar. Therefore, the geometrical moment of inertia should be Bd cube by 12. Bd cube by 12. So, I am rewriting the formula. Y is equal to m g L cube divided by, I am cancelling 3 and 12, I will get 4. Then this is taken to the numerator. I am writing it here. By B d cube capital Y in meters. So depression, mass, gravity, the length, breadth and thickness, Young's modulus of the beam. So I am substituting the value 4. The mass is given as 0.1 kg. We are on earth, therefore it is 9.8 m by s square is the g value. Length is 1.5 meter, the whole cube, divided by breadth value is given as 0.024. Thickness is 0.005. The whole cube. Young's modulus value is 9.78 into 10 power 10. Double bracket 4 into 0.1 into 9.8 into 1.5 the whole cube power 3 divided by, open bracket, 0.024 breadth into thickness is 0.005 the whole cube into 9.78 into 10 power 10. I'm closing it with double bracket is equal to, I've got 0.04509. 0.04509. So I'm writing it here. The depression y is equal to 0.04509 in meters. Next problem is, a circular and a square cantilever are made of same material and have equal area of cross section and length. Find the ratio of their depressions for a given load. So no number parameters are given here. Instead, they have given it as what is it? One is circular and another one is square cantilever. They are made of same material. So the material is same. So the Young's modulus will be same. Equal area of cross section. So area for circular is equal to area for square. The length is also same. The length of circular is equal to square in meters. Find the ratio of their depressions for a given load. So for load given, whether it is mass or if it is force, it will be equal. So the load W is equal to W, same. So all these are same for both the parameters. We know the formula for a cantilever as y is equal to WL cube by 3YIG. If it is circular cantilever, I am going to write it as C. In geometrical moment of inertia also I will write C. If it is square cantilever, I will write it as depression with a subscript S and the geometrical moment of inertia with the subscript S. So I am rewriting the formula. So the question is a circular and a square cantilever. So I am going for a circular YC is equal to WL cube divided by 3YIG with the C, and YS square cantilever is equal to WL cube divided by 3Y geometrical moment of inertia of a square cantilever. So the problem is about find the ratio of their depressions for a given load. So ratio is 1 divided by the other. Therefore YC by YS, here also I am doing it the same. W get cancelled off. L cube 3Y, and then the denominator of the denominator I am raising it to the numerator. Therefore I will get YC by YS. Depression for circular and depression for square cantilever is equal to IGS divided by IGC. So what is the geometrical moment of inertia for a square cantilever? It is A power 4 divided by 12, and for circular cantilever it is pi r power 4 by 4. So 4 and 12 3 times. I am rewriting this as A power 4 by 3 pi r power 4. So here I have A power 4, here pi r power 4. Now I'm going to write it as the area for circular cantilever is equal to area for square cantilever. So for a circle, area is pi r square. For a square, area is a square. Therefore, pi r square is equal to a square. Then what is pi r square is equal to a square? I have a power 4 here. Therefore, a power 4 is equal to, I'm squaring it, I'll get pi square r power 4. So, I'm going to write a power 4 as pi square r power 4. So, here I'm rewriting it as a power 4 is replaced by pi square r power 4 divided by 3 pi r power 4. R power 4, r power 4 get cancelled off. Pi, the remaining is pi by 3. So, the ratio of circular and square cantilever, the depression is pi by 3. The next problem is, in an experiment, a uniform rectangular bar of 1 meter length, 0.02 meter breadth and 0.003 meter thickness is supported on two knife edges which are 0.7 meter apart, with the loads of 0.2 kg are hung from both the ends. The elevation of the bar above its normal position is found to be 0.0022 meter. Find the Young's modulus of the bar. So listen, it is about a bar of 1 meter length. So the total length is 1 meter. It is supported on two knife edges. Let this be two knife edges. These are 0.7 meter apart. So the total length is 1 meter. The distance between two knife edges is 0.7 meter. So the remaining should be the remaining should be 0.3 meters. So I'm taking this as A and A. So 2A plus 0.2A plus 0.7 meter is equal to 1 meter. For 2A is equal to 1 meter minus 0.7 meter, I'll get 0.3 meter. Therefore, A is equal to 0.3 by 2. I'll get A as 0.15 meters. Writing the given data now. The length is 0.7 meter. The breadth is 0.02 meter. The thickness is 0.003 meter. And then the load M is 0.2 kg. The elevation is given as y is equal to 0.0022 meters. Now the formula for uniform bending is, because it is loaded at both the ends. Therefore, the solution, Young's modulus y is equal to, the general formula for finding out depression is y is equal to W A L square by 8yIg. The geometrical moment of inertia should be replaced by BD cube by 12, 8 2 times, 12 3 times, and then W should be replaced by M into G. So rewriting the formula here, thereby I'll get W as mg a L square 2b d cube, here Young's modulus y. I am interchanging these two. Therefore, y is equal to 3mg al square divided by 2b d cube into small y Newton per meter square. Now the question is, the value of a is also taken. Though it is not given, we need to calculate it. The total length is 1 meter. The distance between two knife edges is 0.7 meter. The loads are hung from both the ends. The a value is from the load to the nearest knife edge will be a. So similarly, I'll get another a here. So 2a plus 0.7 is 1 meter. The total length is 1 meter. Therefore, I want to know a. Therefore, I am writing this. 1 meter total length is shared by 2a plus 0.7 meter. Therefore, 2a is equal to 1 minus 0.7 is equal to 0.3. a is equal to 0.3 divided by 2. I'll get 0.15 meter. Now, substituting the value of all these, I'll get 3. M value is 0.2. G is 9.8 and A value is 0.15. L square is 0.7 the whole square divided by 2 into breadth is 0.02 and thickness is 0.003 the whole cube into y is given as point elevation here 0.0022. So I am using the calculator here. Double bracket 3 m is 0.2 g a l square 0.7 the whole square divided by 2 b d cube into y, closing it with double bracket, is equal to, I've got 1.8189 into 10 power 11. So Young's modulus of the given beam is 1.8189 into 10 power 11 Newton per meter square.